We're the Bubble Bros, and we chose to make a bubble machine to compete with on Freshman Engineering Design Day. Our basic task was to build a machine that would blow bubbles automatically for at least 1 minute at the flip of a switch. Before we started designing our machine, we checked out the specifications and made a list of the criteria our machine had to meet, as well as figured out what we were not allowed to do. We spent our first meeting making the to-do and not-do lists, as already mentioned. We also did some basic research on some of the physics behind bubbles themselves. We found out that, apparently, bubbles are made of 3 layers, 2 layers of soap encasing 1 inner layer of water. Glycerin is said to be a really good ingredient to add to water to make bubbles. We eventually decided to include it in our final bubble solution recipe. Bubbles apparently tend towards certain configurations when there's no outside force acting on them. Our second meeting was when we began to actually brainstorm designs for our machine. We put the glass-top tables on the first floor of the library to use, with probably a good hour of drawing random schematics of what we thought might blow some bubbles. At this point, once we knew little about what we were actually going to build, we considered what all we would need for the bubble machine construction. None of us had any bubble wands, so we figured we would need to go buy those at some point. It was fortunate that we already had most of the other stuff we would need. The third meeting was short and sweet. We got our parts together and took an inventory, making sure we had almost everything we would need to make a functional bubble machine. Our fourth meeting was the one in which we actually began to build the bubble machine. It was really convenient that the motor came from a set of prefabricated model parts because we were able to put together the gear assembly in a good 15 minutes. We had to drill 8 holes in 8 bubble wands and screw them together into a wheel that would fit on an axle, which was also conveniently a part of the old model kit we used for the motor assembly. And lastly, we had to make a platform to support the fan, motor, bubble wands, and bubble basin. We ended up just using a board of wood with some well-placed screws and blocks of wood to keep things in line to achieve this. We started testing a few days after we finally got our machine together. The first test was unsuccessful as the fan wasn't close enough to the bubble wands. If you look closely at our machine, there's an extra unused hole in the wooden part towards the back. That's where we put the fan in the first place. The first attempts at a homemade bubble solution weren't great either. However, with a few experiments, we were able to develop a much better solution, and it worked a lot better, creating much more bubbles. We also moved our fan to a more effective location on the board. Another big thing our group had to deal with was scheduling conflicts. Several of our members had regular conflicts with common meeting times, so we had to work around those. We had to employ good communication skills to make sure that we had enough meetings to get the project done on time. We created a second bubble wand in order to make the machine capable of altering bubble size and frequency, but we ran into trouble when we were testing the second wand. No bubbles would ever come out despite changing the angle of the fan to pretty much every configuration we could think of. We just decided to scrap this because it was only for bonus points anyway, and through over an hour of experimentation we were never able to get it to work. This was probably the most frustrating hardship we had to deal with in our entire project. We went through many iterations of design to arrive at our final machine. On several occasions we had the machine blowing bubbles, but we decided to try to improve it just a little bit more. We all believe that just because something works doesn't mean it's finished. However, we also came to the conclusion that it isn't feasible for a bunch of first-year engineering college kids to make a world-class machine. We had a really good time working on this project, but it was definitely a learning experience for us all. It took some serious coordination to get everyone to all the meetings we needed, and we had to do some significant scrounging for materials for our project. Perhaps the biggest lesson we learned was that operating a fully functional bubble machine indoors is not the greatest idea, especially when inside a computer lab.